To solve number 11, the difference quotient problem, I do it in two steps. My first step is to evaluate or compute f of x plus h. Okay, so step one, compute f of x plus h. So if you want to compute f of x plus h, wherever you see an x in your function, you got to replace it by x plus h. Okay, so our function only contains one x. It comes right after the number 15. So we should have 15 times x plus h minus 1. So when I distribute the 15 inside the parentheses, we get 15x plus 15h minus 1. That is f of x plus h expanding, okay? Step number 2 is where I say we tackle, I put that in quotes, tackle the difference quotient. What do I mean by tackle the difference quotient? Well, the difference quotient says that, okay, you take a difference, you have to do some sort of subtraction. We're going to do that in this step. And we're also going to take care of the quotient, namely the division. So what I like to do is put brackets around the f of x plus h terms and brackets around f of x. The only thing that's going to be separating them is that minus sign. So we have 15x plus 15h plus 1 minus 15x plus 1, or minus 1. Sorry. They should have been minus 1s. All divided by h. Now, whatever they have in common between the two brackets, you can cancel it out. For example, they have the 15x in common. They have the negative 1s in common. So you can get rid of it. If you do, you'll get 15h over h. And as long as h is not equal to 0, the h's will also cancel. And you'll get 15 as an answer. All right. So this one was a relatively simple question because it was a linear function. The difference quotient is, long story short, is a fancy way of saying slope. So because if you know your slope of a linear function, you'll always get back the slope of that linear function as an answer. But if you have something like a quadratic function now, it's a little bit different. Okay, so let me just do a follow-up example to this. Okay, so follow-up example. Let's say we have g of x was equal to 3x squared minus 7. Okay, so again, I'm going to do it using this two-step approach. So step one, I want to find g of x plus h. Okay, so g of x plus h means that, okay, now we will have 3 times x plus h squared minus 7, right? X plus h is replacing the x in our function. But what I need to do here is expand this. So I'm going to rewrite x plus h squared as x plus h times x plus h. And I'm going to FOIL that out. So I'm going to take x times x. I'm going to take x times h. Okay, so we'll have the 3 still on the outside. X times x is x squared. X times h is xh. Then we do h times x, but h times x is still the same thing as x times h. And then you do h times h, which is h squared. Okay, minus 7. You could combine like terms inside that parentheses. You get x squared plus 2xh plus h squared minus 7. And then you distribute the 3 inside the parentheses. So this gives you 3x squared plus, 3x squared plus 6xh plus 3h squared minus 7. So that's exactly g of x plus h. The next step now, step 2, is to tackle the difference quotient. So again, rewriting the difference quotient in terms of g, we have g of x plus h minus g of x all divided by h. So g of x plus h is exactly what I had from step 1. 3x squared plus 6xh plus 3h squared minus 7 minus the original function, 3x squared minus 7, all divided by an h. So the purpose of the brackets is so that whatever terms that they see in common, I could just cancel it out. So the terms that they have in common are the 3x squares, the negative 7s. What we're going to get is 6xh plus 3h squared over h. You could factor an h out of the numerator. As long as h is not equal to 0, those h's will cancel. And the difference quotient for this example, the final answer would be 6x plus 3h.